Welcome to the first slideshow for Unit 2, Population. Today we're talking about density and distribution. This first image is a great one because this is the Shibuya Crossing, famous in Tokyo, Japan. If you remember the movie The Fast and the Furious Tokyo Drift, this was a starring role for this little intersection, a seven-way interchange. One of our best spring break trips was we went to Japan and we actually took kids to this train station and we walked across the Shibuya Crossing. Pretty cool stuff. So today, talking about density and distribution. So population statistics, we have a lot of quantifiable data, of course. The Greeks were the first to really talk about demography, or the study of population, age, sex, ethnicity, all of those kinds of characteristics. When you fill out a form, sometimes they'll ask you for your demographic information. So demographics, or population geography, really basically boils down to two key statistics: density and distribution. You guys are somewhat familiar with density because in middle school you probably learned that formula, mass divided by volume. In this case, the mass is going to be the number of people, the volume is going to be the unit area. Whether it's square kilometers or square miles, it really doesn't matter. It's still just going to be mass divided by volume. Distribution, on the other hand, is more of a pattern. So this is going to be something where geographers look for a visualization. Where is the distributive center of U.S. population? If you take the middle of our country and you have equal numbers of people north, south, east, and west of that specific point, you'll be somewhere near Plato, Missouri. There's actually a plaque that the Census Bureau puts out there, and that movement has been west and south over the last 200 years or so as the population of our country continues to go towards Florida, Texas, California. Used to be a long time ago, our population was more centered on the East Coast. For the first time in all of human history, more people in the world are now living in urban places rather than in rural places. So that's, again, a measure of distribution. Where are these people located? And then if you change scale and look within the megacities of Asia, you'll find that a lot of the residents of these cities are living in the slum areas. So again, there's a high density of people in those areas, but the distribution is where are the people across space. Different types of maps, of course, are really good for showing density and distribution. You've already worked with some of these maps before. I showed you one of these maps in class today, and today being September 9th. But if you look at these types of maps, choropleth maps are either colored or shaded, usually good for density. They're going to show you that darker colors usually mean more of a density of population. If it's a distribution map, oftentimes those are going to be dots because the dots will show you the pattern better. The problem with dots is that in a dense area, the dots are on top of dots. And the problem with choropleth in trying to show distribution is that the choropleth will show you the density of color, but it won't show you where exactly those people are. Why would you ever use an isoline or a cartogram? Different ways to show the material as well. In class, I showed you a cartogram of Asian countries that are big rice producers. An isoline map, remember, is the one with the squiggly lines. You usually see those on the Weather Channel a lot when they're trying to show you temperature changes in the water with a hurricane approaching or something like that. So this is a cool little analogy where we're showing you density and distribution in three exactly similar pieces of land. The physical terrain is the same in all three images. On the top, you'll see that if you count up the houses, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 houses. So there's going to be 24 houses, and let's say this is a square mile. In the second picture, you can easily see we have more houses in that square mile. So the density went up. But the distribution, if you notice, the road is the same. It's the same road pattern. So the distribution of the houses is quite similar, but the density is greater. On the bottom picture, what'll be interesting is if you count up the houses, you'll find that the middle one and the bottom one have the same number of houses. It's actually 32, if I remember counting correctly, instead of 24 up at the top. But here the distribution is much more different. Here the distribution is kind of spread out evenly. Here it's a much more linear pattern. The houses pretty much follow just two main roads, and there's not as much housing taking up the space in the middle. So a land developer looks at both density and distribution when they're planning out how they want to build these neighborhoods. You probably can see that in your neighborhood. World population density, of course, we walked around on my big map outside that your parents will get to see at open house on the 10th. But here, what we're using is an isoline map that's also been colored so that you can see the variation from low density up to high density. And what we're looking at, obviously, China and India, really dense populations, very big populations, but also Europe, the eastern portion of the United States, the area around Mexico City, the area around Rio, Sao Paulo, perhaps, Buenos Aires, the area around Nigeria, particularly the old capital city of Lagos, along the Nile, East Africa. This is the country of Ethiopia here. Obviously, the Philippines, Indonesia, Japan, the Koreas, areas of dense population. But this is, again, a good way to show density. If we wanted to show distribution, we'd probably want to put it in dots. Again, areas of great density, the dots are on top of dots, and you really can't see very well. So distribution will show you the spread, but in areas of great concentration, we would prefer maybe a choropleth or even a cartogram to show those density numbers. Again, you can see Nigeria, you can clearly see the Nile, look at both China and India, look at Indonesia, particularly the island of Java, which is where the capital city of Jakarta is. And Jakarta just in the news lately because they're thinking about moving the capital city because it's overcrowded, because it's sinking, it's in an area that's physically not the best site for a city. Remember, we talk about those words, site and situation. This is kind of a similar map, except this is the Earth at night. And NASA basically put this together. It's not night on the entire Earth at one time, but they put it together with a series of images. And what's cool about this is it doesn't just show you the population, but now we've added in the factor of technology, because obviously areas with greater economic development are going to have more light at night. You can see, for example, the Sahara, the great outback of Australia, the Gobi Desert in China, the Amazon Basin in Brazil, the Arctic tundra of northern Canada and Greenland and Siberia, places that we generally don't live. And remember, we don't live in areas that are too hot, too cold, too wet, too dry, and too rocky. So you can see the population concentrations, the Asian countries, big here, China, the Pacific coast of China, right, the area of India, and you can actually see the Indus River Valley in Pakistan. Japan, of course, really lit up. South Korea, but look, North Korea is super dark. Not because there's less people per se, but also because there's just no electricity after dark in Kim Jong-un's regime. Again, Sao Paulo, Mexico City, you can really see the Bosnia-Wash corridor of the United States, that Boston, New York, Washington, D.C. area up and down I-95. It's really cool when you start to see these patterns. Here's a cartogram similar to what I showed you in class, but we showed you one about rice production. Now, this is pure population. China and India, again, the two biggest ones. You'll notice that there's a lot of distortion over here in Asia because remember, out of the 7 billion plus people in the world today, 4 billion of them are living in Asia. About 1 billion in Europe, about 1 billion in Africa, and remember the entire Western Hemisphere is only about 1 billion. So you do the pin code of the world for population, it's 1, 1, 1, 4. But remember, in your lifetime, Africa is going to triple, particularly places like Nigeria, where fertility is still high. And places like Europe are going to continue to shrink because they just don't have large family sizes and they're getting old. And you know what old people tend to do? They tend to die much more frequently than anybody else. Here's another way that you can do a cartogram. In this case, each square or each block is representative of 1 million people. So if you have a country of less than 1 million people, you don't even get a block. This little place right here, that's Trinidad and Tobago. Their population is 1.1 million, so they only get one block. China and India, over 1 billion. That means that they would have thousands of blocks, right? And in the United States, there should be a little over 300 blocks because we are 325 million people currently. China and India will flip-flop their order. India is still growing a little faster than China. So pretty soon we'll see India, the most populous country in the world. They are the 1 and 2 by far. The United States is 3, Indonesia is 4, and then of course after that we go through the top 10 that I'll show you in just a second. So here they are. China's still a little bit bigger than India, but as I said, India is still growing slightly faster than China. The United States, Indonesia, Brazil, Pakistan, Bangladesh, Nigeria, Russia, Japan, rounding out that top 10 or so. All of the other countries in the world, less than half of total global population. Interesting statistics, quantitative data. Here's the one kicker. If we had done this the other day walking around on the world, it would have been cool to kind of simulate this with all of the students walking on the map. But essentially, there are more people living inside that circle than there are people living outside of that circle. But of course, you go back to the chart I just showed you and you look at all the countries that are in that circle. China and India, both in that circle. Indonesia, in that circle. Pakistan, pretty much in that circle. Bangladesh, 100% in that circle. Japan, in that circle. Even Vietnam, the Philippines, Thailand. These are countries with 40, 50, 60, 70, 80 million people or more. And that's why you get more people in that circle than you have people living outside of that circle. Remember, South America, a big empty space in the Amazon. The North American continent, a big empty space. Canada is only 30 million people to our 300 plus. Mexico, obviously a little over 100. So they're somewhat big. In Europe, remember that there aren't very many countries there with big population numbers other than Russia, and most of Russia's population is European, by the way, a little over 125 million or so. But you start to get to Germany. Germany's only 85 million, right? France, less than that. Spain, even less than that. The UK is about 65 million. So when you add all of it up, it turns out to be a lot. But again, more people in this circle. Africa, again, about 1 billion or so total. Nigeria is almost 200 million. That one is growing fast. It's an area the size of Texas, but pretty soon it's going to be 400 million people, probably in the next 35 to 40 years. So hopefully these statistics are interesting for you. Hopefully it helps you understand a little bit about density and distribution. We'll be back with another slideshow shortly for the second part of Unit 2.